Hello, this is the video for lesson 1, video lesson 1 for unit 4 of our trigonometry class. This video is entitled Graphs of Sine and Cosine Functions and Changes in Period and Amplitude. Before you begin watching this lesson, I'd like you to pause the video if needed to go find the packet that has the sine function and the cosine function in it. If I remember correctly, that is on yellow paper. So you need to go find the packet that has the main sine function and the main cosine function in it, as well as the packet for your video notes. You need both of those in front of you. Okay, now that you have both of those packets in front of you, we can remind ourselves of what the sine and the cosine function indeed look like. You should have in your packet the sine curve, and the sine curve should be the one that starts at the origin and then has a hill and then a valley. And we discussed this the other day in class. We said that this is an example of a periodic function. This is a function with amplitude 1 because the distance from the midline up to the top of the hill, this distance right in here, is 1. And so the amplitude is 1. And we said that the period of this function was 2 pi because the length of one cycle of the function is 2 pi. So this is the period. We mentioned that there are variations in the sine curve, where if you insert a multiplier out here, a number that we would call a, that's going to stretch the amplitude and possibly flip the function over if a is negative. And this b value impacts the period. Okay? Also in your yellow packet, you should have a copy of the cosine curve. The cosine curve should look like the following. It should look exactly like the sine curve, except that it's split over a little. So this is like the spaghetti graph that we made in class together. You graphed that much of it, the part that's green right now on the screen, is what you graphed in class. But if you had extended it further, or if I'd asked you to do more cycles around the unit circle, you would have this graph. Okay, so this is the graph of cosine. Okay, both of these things are very important. Both of these curves are very important to remember because we're going to do some variations. So I mentioned in your printed notes that we have discussed functions of that form, a sine bx or a cosine bx. And we've talked about the fact that when you look at this number that's up in front, and just kind of ignore the positive or negative sign, or in other words, take its absolute value, that number is what is called the amplitude. Okay, it's how high the hills are or how low the valleys are from the midline. Okay, so this is the midline. An amplitude is a measure of those hills and valleys from the midline. This is a formula for period. So if you have a different number in with the x, so we did one in class the other day that I think was something along these lines where there was a 2 here. You have 2 pi over this 2. The 2 is the b. So 2 pi over b gives you the new period. And so a period of pi means that instead of your graph taking this long to have a full cycle, you have a full cycle in half as fast. Or in other words, 2 cycles fit in the normal length. Okay, so that's what that 2 means. 2 cycles would fit in the normal span. Okay? Today we're going to take this knowledge and go a little bit further. Okay, the first variation that we're going to add into the mix is if you have a number out here that you are adding or subtracting. Okay, so adding or subtracting with the x, so to speak, is going to create a horizontal, and that means side to side, a horizontal shift or a horizontal slide. Because there is a coefficient with the x, we need to do a little bit of work to make sure we understand exactly what the slide is. Now for cosine or for sine, one cycle typically goes from 0 to 2 pi. And so if we were to just think, okay, it's normally going to start from 0, but that's when there's just an x here. If there's bx minus c there, what happens is we'll solve for x now, bring the c to the other side, divide both sides by b, and we find out that the starting place, so to speak, is C over B. So rather than starting our cycle from 0, we're going to start our cycle from C over B and then figure out how long the period is to know where it's going to end. Okay, here is an example to try to explain what I mean. All right, we're going to line this up with this general format. Okay, so as I look at this, some things that I would write down off to the side, and the more off to the side writing you do at the beginning, the easier it is to actually graph. I would write down what A, B, and C are. So if I match this up, A is in the, or the 3 is what's in the A slot. B is the number multiplied by the X, and there doesn't seem to be anything there, so that means it's just one X. B is 1. And C is pi over 4. Notice that this minus is baked right into the formula, okay? So the fact that there's a minus here is not important. That minus is the same as the other minus. And the C is pi over 4. Okay, now each of these values tells me something. The A tells me the amplitude. Amplitude in this case is going to be 3. The hills and valleys go up and down 3. B is usually what affects the period. Period is found by 2 pi divided by B, but B is 1 in this case. So the period is just 2 pi, which is the normal period anyhow. And then what we just saw on the previous part here was that dividing C by B is going to give me how much slide there is, okay, how much horizontal shift there is. So I'll call that HS for horizontal shift or horizontal slide. That's equal to C over B. And in this case, C is pi over 4, and B is just 1. Dividing something by 1 doesn't do anything. So horizontal shift, pi over 4 divided by 1 is just pi over 4. So this means that rather than starting my graph from the origin, I'm going to move it over. Now, this graph isn't labeled at all, so I have to first think about what my labels should be. Since the slide is pi over 4, it would be kind of convenient if this could be pi over 4. Pi over 4 is the same as 45 degrees, so I could make this pi over 2 and make this 90. This is 90. This would be 180 for pi. This would be 3 pi over 2. This would be 2 pi. So aside from the pi over 4, which I'm actually going to erase for a second, you see that every other mark is counting by 90 degrees. 90, 180, 270, 360. That's what we have labeled right now. So I could put another mark here and another mark here. This would be 3 pi. This would be 2.5 pi, or 5 pi over 2. Okay? So you don't need to label every single tick mark, but you do need to label in such a way that the spacing is equal throughout. Each of the tick marks that I've highlighted in green is 90 degrees away from the one next to it, okay? And then the ones in between that aren't highlighted, those are 45 degree marks, okay? The horizontal shift is pi over 4. That is equivalent to this much space, one tick mark, okay? So I need to bear in mind that I'm graphing sine, and my sine curve is going to start from here. How long is the period? Well, it's 2 pi. 2 pi is from here to here, except we've shifted over, right? We've shifted over that much, okay? So rather than starting at 0 and ending at 2 pi, I'm starting one tick mark to the right of that. So my end is actually going to be here. Now, when we think about the sine curve, look back at your yellow packet. You see how sine has this shape? That is exactly the shape that I need to have on this graph. Let's count in and find where the middle of the graph is. So I count in 1, 1. You don't have to actually draw this. You can actually just do this with your fingers. I'm just drawing it because you can't see my fingers, okay? The exact middle is this point. Okay, so I have a beginning, an end, and a middle. That would correspond to this point, and this point. Now I need to figure out where the peak and where the valley of my sine curve would be. Well, halfway between this point and this point is right here. That's where the peak needs to be. Now, how high of a hill does this have? Well, it says over here that my amplitude is 3. So I need to go up 1, 2, 3. 1, 2, 3, boom. See, even with the 3. And my valley needs to be between this point and this point. So halfway between those would be right here, and I need to go down 3. Okay, I'm kind of erase these extra arrows that I use just for pointing. Oops, erased a little too much. Okay, and I'm going to connect these red dots with a nice smooth sine curve. There is one cycle of the graph 3 sine quantity x minus pi over 4. Okay, the pi over 4 made it slide over. The 3 made it have a larger amplitude. And those were the only changes in that graph. Let's look at another. Okay, this one's based on cosine. So do make sure that in your packet you're looking at the cosine graph, not the sine graph. When I'm looking at my cosine graph in my packet, I notice that it looks like this. It's beginning and end, middle, and then a couple points in between. That's the shape that I'm going to need to fit into my graph. If I line this up with y equals a cosine bx minus c, let's identify what a, b, and c are. A is 1/2. B is 2. C, now remember how the formula has the minus baked in? Well, this is a plus. So it's like 2x minus negative pi. Or you can just think of it as it has to be opposite. So C is negative pi. The amplitude comes from A. So I know this graph has to have an amplitude of 1/2. The period is 2 pi over b, which in this case gives us a period of pi. And the horizontal shift is c over b, which in this case is negative pi over 2. See how the b is 2? What this means is my graph is going to shift to the left. The negative here indicates a slide to the left of pi over 2. Okay, now I need to think about how to tally this up. I'm personally thinking that this is going to be negative pi over 2, or negative 90 degrees. That would make this, since it's 2 tick marks away from 0, positive 90 degrees. This would be, since the 2 tick marks make 90, 2 more tick marks make another 90. This would be 180, 270, 360. Okay, so kind of similar to what we've seen in other graphs. All right, now we're going to draw our cosine shape, and it's going to be slid over. In this case, I think it might be easier to draw the graph first and then slide it. So I'm going to draw my first, like my rough draft in green, and I'm going to slide it over and draw that in blue. Okay, I'm going to ignore the slide for a second and just work on the amplitude and the period. The period, it says, is pi. So I'm going to fit my shape for cosine into this width with an amplitude of 1/2. So this is going to be very low. Okay, I know that cosine looks like this over here. So I'm going to put a beginning and an end dot, those 2 dots there. I'm going to have a middle dot here. That took care of this, this, and this. Now, halfway in between a hill and a valley, I need the crossing of the midline. So that would be those 2 right there, okay? And now I'm just going to draw this myself kind of dotted or light. If I were using a pencil, I'd draw it very, very light with my pencil. Now, the reason I drew it light was because although this graph took care of the amplitude and the period, both of those are in my picture, I did not slide my graph pi over 2 to the left yet. Now I will do that. I will take each of these key points. So this point slides over to here. This point slides over to here. This point slides to here. This 4th point is going to slide to here. And this point is going to slide over to here. Notice that each point moved 2 tick marks because 2 tick marks, 1, 2, puts me at negative pi over 2. And that is what it said over here was the horizontal shift. Going left, pi over 2. And now we're going to connect the dots. Okay, if I needed to do another cycle, we shortcut. This is a very shallow curve. It's not oscillating very high or low. And it has a smaller period, a period of just pi. Let's look at another one. All right, this has a lot going on. Okay, I'm going to look back at my graphing packet, my yellow packet, and see that here's my sine curve. My sine curve has these 5 principal points. In this graph, I'm going to line up a sine bx minus c, and I'm going to identify a, b, and c. A in this case is negative 4. B in this case is 1/2. C is pi. Remember that the minus signs match up, so C is actually just the pi, not negative pi. This tells me that the amplitude is 4. But the fact that A is negative means there's also a flip. The hills and the valleys are going to change. B, being 1/2, is going to tell me about the period. Period is 2 pi over B, which is 2 pi over 1/2, which is 4 pi. So this is going to be stretched out and be much wider than usual. And C tells me about my horizontal shift, which in this case, the C over B is going to give me pi over 1/2. Remember how you divide fractions. You multiply by the reciprocal. So our horizontal shift is 2 pi units, and that's to the right since my horizontal shift ended up being positive. So I'm going to use the strategy we used in the last question and graph first and slide after. Now, since the period is 4 pi, I do want to make sure that I kind of count by larger amounts this time, just because I want to make sure I can see enough of the graph. So how about we make this pi, this 2 pi, this 3 pi, and this 4 pi. So these segments represent much larger units of length, or much larger values. Okay? So that's how I'm going to tally things up. Amplitude is 4. If we count by ones, 4 is way up at the top. Okay? So I'm going to have a sine curve that has hills that go all the way to the top of where I've labeled. I think we're ready to go. Okay? The period is 4 pi. This length right in here is from 0 to 4 pi. So that's how wide my function is going to be. Again, I'm going to draw it dotted just for practice, kind of, and then slide it after that. So sine would start from here. It would end here. It has a middle here. That was this point, and this point. Okay? Now, halfway between the first 2 x-intercepts, there's a hill. So that would be here. And these, between these other 2 points, there's a valley. And I'm just going to draw this dotted because this is not my final answer. Although this graph takes into account the amplitude, there are a couple of things I didn't take into account. I haven't done the flip yet, and I also haven't done the horizontal shift yet. Let's try to incorporate both of those things. All I incorporated was the period and the amplitude itself. Okay? The flip would make my hills and valleys change places. So let's do that first. Okay, so now I have my blue graph. That's not quite it yet, though. I'm going to take out the green as best I can without messing up anything else. Okay, so there's some extra little marks in there. Sorry about that. Okay, but now I've taken into account the flip. So this is done. Flip is done. Did amplitude of 4, have the right period, but I don't have the horizontal shift of 2 pi yet. So now I'm going to take each of my key points, like this point, for example, is going to slide 2 pi units to the right. So now that's here. And then this point at 2 pi would slide to 4 pi. And the point that was at 4 pi would slide to 6 pi. And this valley down here is going to slide over 2 pi. So it's at pi right now. It's going to go to 3 pi. And this hill that's at 3 pi is going to end up at 5 pi. It slides right over. Okay? That's the sliding over. And now I'll connect those points. And actually, this is my answer because now this takes into account everything that was in the graph. Okay? The black part is my final answer. If I wanted to, I could leave that dotted stuff as like showing my work, or I could take it out so it's more clear. Okay? There's one cycle of my final graph. Okay, here are some more examples. This example brings in something we haven't talked about yet, but we will right now, and that is adding a value right here. Okay, so our final form of everything is really this. Okay, we've talked about this part so far in the lesson. If you have another value right here, that value is going to cause the midline of your graph to slide to somewhere else. And it's actually the easiest thing to graph. So in this case, the fact that there's a 3 there is just going to bring my midline to right here. And what I would suggest you do is exactly what I'm showing you now. It's just to draw a horizontal line at that value. So D is what's called your vertical shift. Okay, let's do this problem as we have the others, where we bring some values, we write down our values off to the side. So A in this problem is the 2, B in this problem is pi, C in this problem is pi over 2, and D in this problem, as we just mentioned, is a 3. A tells you amplitude. So our amplitude here is 2. We have hills and valleys that are 2 units high. The period is 2 pi over b, which in this case, the pi's would cancel, and we get just 2. So our axis, our horizontal axis, is just going to have regular numbers on it, not with pi's. C in this case is going to, well, actually C not just in this case, but in all cases tells us our horizontal shift. And our horizontal shift is C over b. So in this case, that's pi over 2 divided by pi. Remember how you divide fractions. So we'd have pi over 2 times 1 over pi. The pi's cancel and you get a half. So in this problem, the horizontal shift is a half, and D is going to always tell you the vertical shift directly. Whatever D is, that's your vertical shift. So this problem has a graph that slides up 3, it slides to the right 1/2, it has a period of 2 and an amplitude of 2. It's based off of cosine. And in my graphs packet, I can see that cosine looks like this. The 5 key points are these that I'm highlighting on the blue graph here, okay? Now, I need to think about how to label the axes. I think it would work well, since the period is 2. If I made this 2 and this 1, since the horizontal shift is also a half, it would be really nice to see where 1/2 is in what I tallied. So for instance, I wouldn't want to make on my axis, if this was the y-axis and this is the first tick mark, making that 1 would make it harder to see where 1/2 is, you know, that it's somewhere in the middle there. If I made this first tick mark 10, it would be really, really hard. 1/2 is like right there. I don't know how to see that. So that's what I mean by seeing 1/2. I want it to be easy to note where 1/2 is, okay? If this is positive 1/2, over here would be negative 1/2, okay? And I think this will work pretty well. Maybe I should label a little bit more. This is 2.5, and this is 3, okay? So now I need to bear in mind everything, I think, except maybe the horizontal shift. I think I can do all of it except for the horizontal shift, and then maybe slide that at the end. Okay, so I see that I'm going to need to extend this a little bit because the amplitude was 2, and this is my midline. Okay, so from this midline, I need to go up to and down to from that point. And I also note that there's a period of 2. So this span is the amount of space that I have in which to complete this picture. All right, this line in my blue picture is now the dotted line that I have at 3. So if I go up 2 from 3, this would be at 5. And if I go down 2 from 3, this would be at 1. So my hills and valleys are going to end off at 1 and at 5. That's important. All right, let's try to do this, guys. So cosine starts up high. This point that I'm blackening in is this one right here. And since the period is 2, I would go way out here. That's this point. Halfway between those, which would be at 1, I'm going to be at the lowest point on the graph, which is this. Now remember, since the amplitude is 2, right, I just go 2 down from the midline. This point on the blue graph and this point on the blue graph are what I need next. So halfway between the high and the low, I hit the midline. This is not my final answer though, because this graph, although it incorporates the correct amplitude, the correct period, and the vertical shift, it doesn't have the horizontal shift of a half. So now let's draw our final answer. Our final answer is going to take this dotted graph and move everything over 1/2 of a unit. So that would be here. I take this black dot, move it over a half, take this black dot, move it over a half, and so on. Each one of these going over 1/2 a unit, and then I graph by connecting. And that's it. Okay, so you'll notice if you go ahead in your notes, there's a graph like this. I'm not going to deal with that after all. But what I would like to go back to actually is in your packet, right after this example, there's mention made of how you can look at your calculator to look at sine curves, okay? So let's take out your calculator. If you don't have a calculator handy, you can go get yours. Just pause the video. And it says here we're going to look at 2 graphs on your calculator. So let's go ahead and do that. You just go into your y equals menu like you usually would. Clear out any old junk that you have in there like I have. And then you're going to type in 2 graphs here and just see how they compare to each other. So 3 plus 2 sine x would be typed like that. And then below that, just without the 3, type 2 sine x. I'm going to make sure before I hit anything else that my mode is in radians, which it was not. Here we go. And in the zoom menu, I'm going to pick zoom number 7, which just picks a good tick marks to use with trigonometry, okay? So I'm going to just type a 7 right now. So let's compare these 2 graphs. Okay, so the second one that graphed, if you were watching the screen, was this one. So this graph is just y equals sine of x. Excuse me, that is not true. That is just y equals 2 sine of x. Sorry, I forgot that there was a 2 in it. And up above is the graph of y equals 3 plus 2 sine x. So what this shows you is how this number here just takes our graph and slides it up. All of these points are slid up. That one's even off the screen, okay? But what that was just showing you is that the D makes a slide. Now you might be wondering, well, why don't I just do this? Well, I'll tell you why. Why do we graph by hand? You look at your table, look at these values. Even if I manage to erase all the ink here, and you look at your table. Oops. These are awkward values to plot, okay? And so this is why sometimes plotting by hand, even though it's challenging, is a little bit easier than taking values off the table because these decimals are so awkward. It's better for us just to find our 5 key points in each interval or each cycle of the function itself, plot those, and then we get a nice smooth curve to draw. Now we will do tons and tons of practice with this in class. It is very challenging. Please feel free to return to this lesson as often as you need. They are some really good examples, I think, and we will be practicing this for the next several days. Thank you so much for watching a very long lesson, and I hope that you were able to glean some information from it. Thanks. See you in class.